Hello everyone, welcome to EduCell. This video we are going to discuss about breadth-first search, or in short we can say it's BFS. I will discuss how BFS will run, which data structure is getting used in BFS, as well as how the algorithm is running uh, to manage to get the correct BFS, as well as we'll read the time complexity. If you are new to this video, kindly watch the previous videos as well as kindly watch the introduction of graph. Then only it could be very much easy for you to understand how the time complexity we are getting, in which directions or in which approach we are getting the time complexity. So all the lecture videos will have the correlations between them. So it's my request, do not visit directly to certain videos without any prior requisites or prior videos. Okay, so kindly watch the introduction before watching this BFS or DFS or any videos. So you should have to go through the introduction first. This is my request. So let us start. Here I kept the algorithm from the book Introduction to Algorithms, written by Corman and all authors who are from MIT Institute. So I'm following the book because I know if I'll start from the book, definitely we should follow certain theme. If I'll teach you in that regard as usual taught by others, that is not well enough to understand. So always the proper thing I am following is to follow the book. Next thing is I'll follow my method, which might be helpful, but before that we should know how book is written, how the information will be written as per the book. We should understand it. Okay. So here, as in the first video, the introduction video, we said G stands for graph. Okay. So here S is stands for your source one. Okay. Or else instead of source you can say the starting node also. The start vertex or start node. Any node you can pick as a starting node or a source node or you can say or a vertex, starting vertex or source vertex. So BFS this algorithm I kept from Corman. Okay, Introduction to Algorithm book written by Corman and other authors. Okay, so here in this book, first of all, BFS algorithm which is written is we have to follow all the nodes present here. I kept the example also from that book. I kept it because we should understand it well first. For each vertex u, which belongs to a v minus s, means excluding this source which you have taken, all the vertices. Let us hear the vertices are r, s, t, u, v, w, x, y. Okay, there are 8 vertices. You have to keep only one vertex as you are a starting vertex. Excluding that, all the vertex which you have right now, you have to keep those vertex in a for loop first. That for loop, what you have to do, you have to follow certain steps where the color of all the vertices excluding the source one is considered as white first. Okay, all are colored as white. Next is the distance. Why we are putting distance? In future, whenever you will read the shortest path time, that time you have to keep in mind the distance are a part of it. Distance will be considered. But right now we are just for running the program smoothly. We are writing a distance. Here, when you code it in place of infinite, you can place any largest value like one crore, 1 lakh, 1 million, 1 billion, whatever the values you want to take. That could be a higher value. Okay. Next is pi represents where u dot d means distance. All distance will be considered as infinity means that infinity represents the largest value which is greater than 0 definitely. Okay. Next is we say it's a nil means uh, we have not visited the predecessors as per the book. It says the predecessors. Okay, so this is how we have to remember first dot color, then d, then the pi which is the predecessors or you can say the previous uh, connected vertices. We can find the previous connected vertices if we visit that. So we say excluding the source one which we are going to visit, everything should not be visited, means we have not yet visited, we remain as it is nil. Okay, for that we have written is nil. Next is, once we pick the first one which is s dot color, means we started the vertex as s, small s we started, so that color will be converted as gray. And the distance, though we started the distance we say as 0, and though we started from that, the previous value is not yet being decided for the time being, so we pick that as nil. And q represents here, the q is data structure we are using is q data structure, which follows first in first out concept. Okay, q data structure we are using, where we are following it. Q, as we know, it's first in first out manner it is running, and we say it's nil. Okay, which is 5 we are saying. Next, once it is done, then we enqueue. Enqueue means we are insert the vertex S. Okay, that means enqueue means we are inserting the vertex S. Once we have inserted, as for the up to this, up to 10, like 1 to 10, what we have done, we have put infinity. Okay, next part is we have uh, set it as 0. In this sixth we set this as 0. Once it is done, next q was considered as 5 before, that means q value is not there, we just declared that q here. Next, once we enqueue this, we kept the value of q as s, small s. Up to this it is okay. Next, until it is infinity, means until there is no such value, we have to run which one, that there is a while loop we run. Within that we have to write the dq. Here dq means we have to remove, you can say remove the vertices present in q. Okay, so we are removing the vertices simultaneously, not one by one, simultaneously we are first removing that one, we kept in the u. Okay, next we will run the for loop. Within the while loop, for loop is running. Okay, so in that for loop, small v is also a part of vertices, but that is adjacent, adjacent to the u. Which are adjacent means those who are connected with you. This adjacent means which is connected with you. Okay, though which has already been deleted, the connected one will be kept as the small v. Okay, now if condition we run, we set whether the v, which one we fixed, like here the connected vertices are r and w. Okay, this r and w, they are directly connected to s. If they're directly connected to s, then we have to say whether we say these are small v for us, we have to say the small v, whether the color is white or not. Yes, of course the color is white. Then what we have to do, we have to set the color as gray. Here we set the color as gray in part b. Okay, once we set that one as gray, then the distance will be distance, previously it is 0, then we add plus 1 there. So which one, the distance which is recently connected to the previous one, previous u, is 1 now. So we have updated as 1, we have updated this as 1. Okay, next is the predecessors, which one is previous to it, is the predecessor is u. U means which has been deleted recently. Okay, so s, it's a previously deleted. Okay, so then nq means we need to insert the v's which we found, like w and r is getting inserted. Okay, after this, then u dot color is equal to black. Clear, no? So u dot color is equal to black means the previous which from which we started, that will be converted as black. Clear? So this is how the algorithm is getting run. Okay. So the first step is we have to, when we start with the source, first that before that we should have to say others are, once we are starting with any vertex, so we should color that one as gray. The distance will be 0 and nothing as they are connected, so it's nil. Okay. And others are, we have to first write as infinity. As for this, up to 1 to 10, it's the initial for us. Up to 1 to 9, it's initial for us. Okay. Next, after 10 onwards, 10 to 18, we are running the BFS. Before that, it's not BFS, it's just initial steps for us. Okay. So in this way, we can find, once we have inserted, simultaneously you can check, once W we are getting deleted W, that time W which are related are T and X. As for this, we first color them as gray, then the distance will be the previous distance plus 1. Previous distance is 1, so 1 plus 1 is 2, 1 plus 1 is 2. Okay. And also the R was there, the previously R was there, so R, the connected one is this one, and it was previously connected, so no need to update that one. Which has not yet visited, that will be updated. So here they collect colored as gray, then 1 plus 1 is 2. So here we got this 2. Before that, which was our S, that we converted as black. Okay. And here we collect the vertices which has been recently been uh, you know recently been inserted, or NQ. So here when we DQ this one, DQW, so we get this one, but R is there as it is, because first in first out, this is first, we have to remove that one, and rest of the thing will be kept as it is. Then TX we will keep this way. Next, R will be deleted. Once R will be deleted, here the immediate will be added here. So like this we will go one by one. So here once it is done, like the previous will be black, so black, from black we, what we say, we will have to write the you can say the BFS. But BFS is not always same for all. It might be changed. Like whenever I am writing, so I'll be first completing this one, then I'll write the BFS array. Okay, or the BFS how it look like. Once we start from S. Okay. So here this is what we have done. Next, T will be deleted. Why? Because first element as per this. So once T we have only connected, like this has already been visited, but only connected is this one U. So we have to insert U the last, because we know first in first out. Clear? So that will be out, and once we are inserting, so we are inserting there. So here you can check. So here, and the value is getting added. As for this, once it is getting, the distance is getting updated, the previous one will be black as per this 18 one. So we have to set black means we have correctly visited, no need to visit again. That is what it means. Okay. Next, when we cut X means we are operating on X. Till date it's not black, so we have to operate on it. If gray, we have to operate. If black, we stop. This is how it is written. Okay. So X, we started with the X. Now we will update. This is already being visited, this is not yet visited. Our first priority is, if it is not yet visited, we have to visit that by writing its updated value as 3. Clear? So we will write it 3 now. So then it is written here as 3, and the previous value, once we have updated the value, we have to black it. Next, V U Y, but the first, this one will be deleted, means DQ. Okay. Once we remove, then only we do the operation on it. Once we do the operations, here already visited, which is connected, so no need to check that one. So rather we will black it. Okay. So we change the color to black. Next, what we have to do, we have to cut the U. As U is there, U already being visited by other adjacency nodes, so that's why what we have to do is we have to check, like the previous lit is visited, so no need to change or no need to update anything. Rather we will change the color to black. Okay, we have changed it. Now y is there. Once you cut that or remove that one from the queue, so 3 will be black. So here you can say on ith we started from a to 9 I, which is the ninth step. On ninth step we got the correct answer. But whenever you are writing the BFS, whenever you are writing the BFS, first time, whenever you are writing on the basis of the updation value, you have to write it. Okay, s, though we started from s, so we are writing s. Either you can write w r, or else you can write r w. Clear now? You can change it because it's up to you. So the connected will be visited first. Next, what you have to do is, once here also v you can write, then also you can write t x. Clear now? Or else you can write x t r also, x t v, because you can change their order could be changed, or anything you can write. Suppose v, you can start vtx xtv, uh, anything, like you can write t, then v, then x, anything you can write, not an issue. I'm just writing two simultaneously. There could be many BFS could be possible, but you, though you started from single node, that single node should be presented well. Next, what you have to write, then u y, or y u, anything. But there are two BFS that I have written. There are many BFS could be possible. Many means the possible the possible combinations. Based on the combinations, you can create the red facets. Okay, this is how we can complete as per the example written by the Foreman, which is the name of the book is Introduction to Algorithms. Okay. Next is, as for the example. If an example is given to you, then how to find it. The correct and easiest approach, if you'll ask me, then I'll just write an example. If it is in a tree manner, suppose in a tree manner, it is there to find the BFS. Suppose, okay, find the BFS starting from, find BFS starting from, or taking source as A. Clear? So in this way, always whenever you are finding BFS, the simplest method is always try to do from left to right. Once it is done, then you go for left to right. Once it is done, you go from left to right. The main reason is, by saying this left to right, the first, once we are selecting this, the immediate connected will be selected. Next immediate node will be selected. This is how it is represented. Suppose for this, first I'll write the answer for it. The BFS will be, once it is in a tree structure, left to right, left to right. A, though you started from A, you have two options. Either you can start C or B, then B or C you can write. Next is D, E, or E, D. Clear? There are many possible ways. Also, another possible way is B, C, E, D. Clear? This is what it will be like this. And here you can say A, C, B, D, E. Clear? There are four BFS could be possible. So any BFS if you're writing, it's correct, because based on the the like you, they're in the same level, and it is connected with the BFS. That's why you can write it. If another questions I am writing, like example 2, starting from S or starting from T, BFS starting from T. So here T, E, G, L, K. So for this example, the BFS could be, I'm just writing one BFS, or might be two if possible, don't worry. But first of all, we should be clear enough. Starting from T, so we have to write it T. if you do not want to use any method, you just simple method you are going to use, or which is with a trick you can say. So the connected will be visited first. Connected are E and G, so you can visit anyone. Clear? So E and G, which are connected, immediate connected, will be visited first. Next connected is L, next connected is K. So here I have written E as first, you can write G as first also. Okay? This is how you can get 2 BFS. So I think it's easy to understand the BFS, but before that we should know how it is running. So based on the, now we are discussing on the note BFS. While using BFS, BFS is using the data structure name Q. Okay, BFS is using the data structure Q. Next, BFS, in BFS, the connected vertices will be visited first. Okay, first we'll visit the connected vertices of the source vertex which has been already been visited. Next, the time complexity. Time complexity. The time complexity here, though we are using adjacency list. So the adjacency list, it is BE that we recently studied, or sometimes we can write it is N plus E. N stands for the, like we discussed on in the previous videos. If you are using adjacency list, clear? If you are using adjacency matrix, that is V square. Based on the representation, we are getting the time complexity. For space complexity, if anyone is asking, you can write V square or N square for the adjacency matrices. We are getting the complexity as V square. Okay, this is how we are actually writing the answers. But always remember that the main difference between tree and graph is tree, there is no connected edges, or you can say no cycles in tree. Okay? No cycle in tree. This is a biggest thing, a biggest comparison between tree and graph. Main reason the tree is not using in map because of this reason. So graph is using because a cycle could be formed. So no cycle is there in tree. Okay, tree is a graph, but graph is not a tree. Means tree data structure could be a graph data structure. But graph data structure is not real data structure because here if cycle is there, it's not tree. But if you can add, if you can remove that edge which is making the cycle, that time you can say it's a graph, it's a tree. So the tree is a part of graph then. Okay, this is how we have set it. Okay, so I think it's understood by you. If any problem, you can comment below, not an issue. And thank you for watching. Have a good day.